3.4 Example for partitioning. In this video, I will run a simple example. We will go through all the details for one partition step. So that's good enough. So you just use the same way you can do, all the possible partitions. All right, so let's start. Let's look at example first. The data given like this, you can see we have 7-element array. Pretty simple. All right, so when we start, let's make the arrangement carefully. Here you can see we do a lot of little things to make the arrangement, in a very careful way. So then we can, we do not want to mess it up. All right, so first we choose the pivot element. The last element we use as the pivot. So you may argue, why use the last element, right? So this is the standard quicksort. After the standard, later, we have many different ways we can modify. We try to improve it, right? So there is one version that's called randomization. So you select random element in this array and swap it to the end of the end position. Then you use that as a pivot, right? So you can do a lot of things to trying to improve the overall performance. But here, let us just work on the standard version of the quicksort. All right, pivot 4, element 4 here. All right. After that, then remember the 3 different regions we defined in the previous video. Here at the beginning, only one region is non-empty here. U region, unprocessed elements, U region. And we use white color, represent the U region elements. Next, now let's start. Here we put one extra space. We need to, when we do the swap operation, we need to use this extra space, number 1. Later we may need number 2, number 3, right? This is the first extra space. Now we are ready to run the partition step. All right, so let us, organize our data in these 3 columns, step by step. When we start initialization, our S region and L region both empty. Both empty. And we will grow these 2 arrays, regions, arrays, subarrays. All right, step 1, we scan from left to right. The first element we see, element 2, compare 2 and 4. And we know we should put it in S region. The first step. We grow S region. Step 2, we see element 8. We do comparison. Element 8 and pivot element 4, it should be in the L region. So we grow our L region. You can see on the diagram, the yellow color, we use it for S region, and the green color, we use it for L region. All right, so next step. Element 7, do comparison with the pivot, and it should go to the L region. So we grow our L region. All right, next. Element 1, this one should go to the S region. So we make its color to yellow. But there is one problem. From the diagram, you can see element 1, element 2, they both in yellow color, but they are separated by that L region. That's not good. All the elements in the S region should be in one block, consecutive elements, one block of consecutive elements. So we need to make that adjustment. When we do it, we want to make a very simple operation to get that. So what is that simple operation? Here you can see we just do a swap operation. Swap element 8 and element 1. After that swap, you can see we put element 2 and 1 at adjacent locations. And the S region occupies whole consecutive block, right? Block with covering consecutive elements. Then that's what we want, right? All right, so let's continue. Next, element 3, it should go to the S region, but because it is also in yellow color, we need another swap operation. Swap element 7 and 3. After that, we will have the current figure. All right? Now the last element, number 5, it should go to the L region, right? So you can see we process all the elements other than the pivot. All the elements other than the pivot. So you can see now we have that S region and L region that satisfy our critical condition, right? But the last thing we need to do, put our pivot in place. So we need another swap operation to put the pivot in place. Let's swap these two elements, element 8 and element 4. After that, you see the pivot element is in place and it separates two subarrays. And these two subarrays satisfy our critical condition. All the values at the left subarray less than or equal to 4, the pivot element, and all the values at the right subarray greater than the pivot element. You can see we make it, right? In this way, we make it. And we do not use a lot of extra space, right? We eliminate those two auxiliary arrays. Pretty good, right? Yes. All right. So now, after that, it looks like we did it. We completed, right? But one last thing we need to do. So that's some technical thing. We need to take care of that part. That is how to control S region and L region, right? You need to do something in your code to maintain these two regions well, right? Here we use two indices to control these two regions. So we use extra space 2 for index I and extra space 3 for index J. Then for S region, in the A array, the portion for from index 0 through I, that portion corresponds to S region. L region, the portion of the original array from index I plus 1 through J corresponds to L region. So to maintain these two regions, basically we just update these two indices, I, J, two variables. All right, Okay, yeah, yeah. So that's before the final swap for the pivot element. Put the pivot element in place. Yeah. So this in place is for the pivot element in place. Yeah. All right. Then change I and J. Yeah, it's pretty straightforward. Yeah. Here I do not need to give you the detail. I think everyone can change it easily. Yeah. Basically, when you grow S region, you just increment I, right? Yeah. Increment in index I. Yeah. When you grow L region, you increment index J, right? Yeah. But at some point, but because when you need to swap two elements, you just do the, standard swap operation. Yeah. Yeah. Other than those things, we can control all the regions very well. Yeah. All right. So that's the most important step in the quicksort partition step. Yeah. All right. So we finish our B.4 right here. Yeah.